Alright, today we are looking at yet another interesting topic in mathematics. We'll be looking at solving quadratic equations. So there are four things that we would want to start by looking at in terms of what exactly are these methods that we'll be using in terms of solving quadratic equations. So in fact, there are four. The first one is called the graphical method. The second one is the factorization method. The third one is the completing the square. And then lastly, we've got what we call the quadratic formula. Now, I should highlight that the first two, these are particularly done in the core curriculum. So this is basically core. And then in addition to these two, the extended learners will be expected to also know the last two, which is completing the square and using the quadratic formula. So for today, we'll be mainly looking at this one, the second method, which is the factorization method. So this is what we shall cover. Now, of course, you might be wondering or asking yourself, what is a quadratic equation? So, a quadratic equation is written in this form: ax squared plus bx plus c is equal to 0. This is a quadratic equation. So, maybe let me also write it here. This is a quadratic equation. Now, once we have something like this, ax squared plus bx plus c, this is a quadratic expression. Quadratic expression. So why is it called a quadratic equation? So the reason it is called like this, first of all, we want to note that the highest power of x is 2. This is what makes it to be called a quadratic expression, where you have the highest power being 2. So anything further than that, it becomes a polynomial. It can be a cubic equation where you've got 3, or it could be a polynomial where you have 4 or even more. So this is called a quadratic because the highest power of x is 2. Then the second thing that you're going to note is these values. The first one is called, it's an equation because you've got an equal sign. This one is an expression because it is just a collection of terms which are separated by a positive sign. So an expression is a collection of terms without an equal sign, and then an equation you always identify by having an equal sign. So the reason I am elaborating on this, or I'm trying to give you the details of what this means, it's because when you are solving quadratic equations, which is what we are looking at today, you will have to start by working out, using what you call factorization, to factorize the quadratic expression, and then you can solve to find the values of x. So I should also highlight that whenever we're solving a quadratic equation, we should have two answers, and those answers should always be values of x, which is why you notice it will be written x is equals to that value, or x is equals to another value. And when we are doing the graphical method, that is where we call that the roots or the solution. So that one will be done on a later date. Now, let me also talk about the value of a. So this value of a is also another important, actually it's the coefficient of x squared. If that value of a is 1, I'll show you a tip on how to solve quadratic equation easily when the value of a is 1. And if that value of a is greater than 1, then in that case, there's a method which I'm also going to show, in which it will be a little bit different from when the value of a is 1. So we've got 4 examples here which I want us to note and solve. In this case, the first one, we've got x squared minus 4x minus 21 is equals to 0. We are asked to solve that one. So notice that I mentioned that we are using the factorization method. So when you are using the factorization method, it basically means we will be doing some factorizations to solve this. So the factorization method. There are two ways of doing this, and I'll be using these examples to demonstrate it. So the first one, I'll show you the tip, as I mentioned, that if the value of a, the coefficient of x squared, is 1, this is how we're going to solve it. Now, maybe to take us back a little bit on how we factorize quadratic equations, or rather quadratic expressions. When you are factorizing, the principle is that since a quadratic equation will have 3 terms, you should find the factors of the constant. So the constant will always be the last term. So it's made out of a power and exponential, which has the highest power being 2. It's got a middle term, which can be positive or negative, and it also has a constant, which can also be positive or negative. So the principle in factorizing a quadratic expression is that you focus on the constant first. Remember, I mentioned this, yonke item ihamba nesine. So look for the factors of negative 21 in this case, in which when you multiply, you get negative 21, and when you add, you get negative 4. So what you can do, you can list them out, list the factors of 21, and then try to find those factors in which when you combine, in multiplication they give you negative 21, and when you add, they give you negative 4. You should notice that, but of course, if you have done this numerous times, you will notice that it will become easy to find the values. So notice that it will be negative 7 and 3. Now let's test it out and see if it works. So the product of negative 7 and 3 is indeed negative 21. And negative 7 plus 3 is what? Negative 4. Now remember, I said I'm going to show you a tip, the easiest way. So you don't need to do a grouping, value of a in 1. So you just say x minus 7, x plus 3 equals to 0. I factorized. And then this becomes a double bracket. And in your spare time, you can always check if you expand this, it will take you back to that. Because the opposite of expanding is factorization. And the opposite of factorization is expanding. So it sort of like goes hand in hand. Now, that means then, this x, because I'm forming a double bracket, this x minus 7 will be equal to 0, or the x plus 3 is equals to 0. Then to solve this is just a linear equation, so it's easy to solve. So plus 7, x is equals to positive 7, and minus 3, x is equal to negative 3. So this is how we solve in a case where the value of a is equal to 1. So the value of a, when it's equal to 1, we don't need to necessarily do a grouping. We just find the factors in which when you multiply, they give us the constant, and when we add, they give us the middle term, or the middle coefficient of the middle term. So to further illustrate this, let us look at the second example. So this was one. The second example is x squared plus 11x plus 24 equals to 0. So again, you'll notice that in this particular quadratic equation, still the value of a, or the coefficient of x squared, is 1. So which means we don't need to do a grouping. Now our constant is negative, or rather positive 24. So two factors in which when you multiply, you get positive 24. When you add, you get positive 11. What are those? I already have them in mind, but I want to hear them from you. When you add, you get 11. When you multiply, you get 24 positive.
3 and 8.
Yes, exactly. It's 8 and 3. So 8 and 3. It's important that you always check. 8 times 3 is positive 24. 8 plus 3 is positive 11. Then, like I said, because the coefficient of x squared is 1, we don't need to do grouping. So we just write x plus 8, x plus 3 equals to 0. Then x plus 8 is equals to 0, or x plus 3 is equals to 0. We form, because it forms a double bracket, and therefore it will form two equations, linear equations. Subtract 8 both sides, x is equals to negative 8, or minus 3, subtract 3 both sides, x is equals to negative 3. So our first value of x in the answer, in the solution or the roots, is negative 8, and then our second is negative 3. So this is how we solve in a case where the value of a is 1. Now let's make it a bit more interesting now and actually look at a case where the value of a in that particular quadratic equation is greater than 1. So this would be a case where still when solving a, x squared plus bx plus c is equals to 0, where a is greater than 1. So of course a can never be equal to 0, because that will eliminate the whole term. So what you notice that in this case that we have, so we're now focusing on the last two. The first one is 3x squared plus 4x plus 1. Now this one, we will solve this in a different method, not in the similar way that we did when the value of a was 1. So in this case, the first thing that we will do, and please make sure that you always remember this, since the coefficient now of x squared is no longer 1, it is greater than 1, we will take that coefficient and multiply it by the constant. So it will give us a new constant, which will be 3 times 1 is 3. And then the next step now, it is look for the factors of the new constant, which we have found by multiplying the coefficient of x squared with the constant. So in other words, factors are 3, not factors are 1. Factors are 3. So you notice that since 3 is a prime number, it has only two factors, 1 and 3. So this is quite easy, 1 and 3. And then we check. 1 times 3 gives us the 3. 1 plus 3 is indeed the 4, which is the coefficient of the middle term. And then again, I cannot stress this enough. X plus 1, x plus 3, we get the wrong answer. The reason is because we no longer have a coefficient of 1. So we are obligated to do the grouping. It's in a grouping. In grouping, the first term will be maintained as 3x squared, and the last term will be maintained as positive 1. Then we are going to write these factors as a sum in terms of x. So 1, which was our factor, becomes x, and 3, which was our second factor, becomes 3x. So you notice that this now becomes plus x plus 3x. You notice that in fact this is the same as that, because if I can simplify this by collecting like terms, it still gives me that previous equation, a previous value on the left hand side of the equation. So let's just figure again. We need to apply your understanding of factorizing common expressions or simple expressions. So you now treat these as a single bracket, because in fact it has become a double bracket, but you treat it as a single bracket so that you can factorize the first bracket separately and also factorize the other or the second bracket as well. So we still have equal to 0 now. So we factorize again. The principle is just to take out the highest common factor. So what's the highest common factor between 3x squared and x? Highest common factor. Now since the highest common factor is the highest value that appears on the first term and the second term in that bracket. The highest. Look it closely. Try again. The highest common factor is going to be x. So sitawukhipha x la sisale na 3x plus 1. So we'll take out x to sala 3x plus 1. Then nana sitawukhipha 1 plus 1 usale 3x plus 1 is equals to 0. Here is another important thing that you should always remember. Now factorize always when you are solving a quadratic equation. La brackets, you should have the exact same terms. Which means la, we are going to 3x plus 1, na 3x plus 1. Once this, what different, something is wrong. This should always be the same, the values that are in the middle. So in answer here, 2 again, sitawuthatha lo x lo simhlanganise nalo 1 kube x plus 1. And then because these appears on both sides, we just take one of the terms. So one of the expressions. So this would be a factorization. Remember, we're solving, but then the first step into solving has to do with factorization first. So we've completely factorized this expression on the left hand side. Now we should solve because we've got an equal sign. So solving a good basis, it's x plus 1 is equals to 0, or 3x plus 1 is equals to 0. So subtract 1 both sides, x is equals to 1. Subtract 1 both sides, 3x is equals to negative 1 divided by 3. So these are the answers. It is x is equals to 1 or x is equals to negative 1 over 3. So this is how we factorize a quadratic equation of the case where the coefficient of x squared is more than 1. In this case it was 3. Now let's do the last one. I'm hoping that this one will provide some clarity. So this one, the first thing that is interesting now, notice 8x squared is equals to 4 minus 4x. What is wrong now? Or what seemingly seems wrong?
What is
0 again, okay, that's one thing you might note. What's the second one? Looks better 0.
Let's set equals to 8x.
So in other words, notice the arrangement, the solo sample. Remember, a quadratic should always have 3 terms and have the highest power of x being 2. So which means what has been done now, the first term of the quadratic is still on the left-hand side. But the last two terms are on the other side of the equation. So which means our first step, it is to move both these values to the left-hand side. So siwamuva njani-ke? Into awumane uyihambise in an equation. You do the opposite operation. If it is positive, you subtract it. If it is negative, you add it. Ukuze ukuthi ihambe to the other side. So which means uhambisa lo 4 lo usitawela njani? Minus 4. So that's total 8x squared minus 4 is equals to negative 4x. I'm trying to show each step so that's the ball I was going to get. Then what happens to the negative 4x? Say add to the other side. So that we will have 8x squared minus 4 plus 4x equals to 0. So we will have 8x squared minus 4 plus 4x is equals to 0. And in fact, I can even rearrange again so that you find the pattern that we are maintaining. So I can have 8x squared plus 4x minus 4 is equals to 0. So this is the proper arrangement of a quadratic, like that. And then we will follow the same procedure, what we did last time. We would say we multiply the coefficient of the first term with the last term. So this gives us negative 32. Then again, we find the two factors of negative 32, which when you multiply, you get negative 32, and when you add, you get positive 4. What are those? I already have them in mind, but I want you to give me the values. Two factors which when you multiply, you get negative 32, but when you add, you get positive 4.
Negative 4 and 8.
Exactly. Negative 4 and 8, or you can just say it is positive 8 and negative 4. So how is that? It's because when you say 8 times negative 4, you are going to get negative 32. And when you say 8 minus 4, you are going to get positive 4. So what you do, remember again, the values of the first coefficient 8x squared remains as it is, and the last term doesn't change as well, or the constant. However, the value that is in the middle, we'll write it in terms of 8x and negative 4x. Why? Because remember, when we're doing the groupings, the total factors A2, we write it in terms of x, which means log 8, so we go over 8x, negative 4, so then negative 4x. So now, we can group the first two and the last two. Please remember, yonke item ihamba nesign yayo. So now you can't just group 4x, you group negative 4x. Now take out the highest common factor. Can you try this one out? What's the highest common factor now?
8x.
Exactly. Now we are getting it. 8x basic saraban x plus
1.
exactly la
Negative 4.
Negative 4. Then the kati it is still x plus 1. Then it's important that you always check. So notice 8x times x is 8x squared. 8x times 1 is 8x, so that's correct. Negative 4 times x is negative 4x, and negative 4 times positive 1 is negative 4. So that one is also correct. So our values for the factorization will be 8x minus 4 and x plus 1. And then of course equate this to 0. And then we solve each, or we separate it into single brackets so that we can solve separately. So let's start by solving 8x minus 4 is equals to 0. So what will be the value there? Or what's the first step? Add 4 both sides, exactly. So that we have 8x is equals to positive 4. Our final step? Divide by 8, exactly. So that means then x is equals to 4 divided by 8 should give us 1 over 2 or half. Then for the x plus 1 is equals to 0, we will simply subtract negative 1 both sides. So the answer is x is equals to negative 1. So this means that the first value of x in our solution is positive half, and our second value of x in our solution is negative 1. So basically this is how we solve quadratic equations using the factorization method. So remember, in summary, whenever you are given a quadratic equation in which the coefficient of x squared is 1, you don't need to do a grouping. Just look for the values of x in which when you multiply, or the factors that in which when you multiply they give you the constant, and when you add they give you the coefficient of the middle term. And then always solve the double bracket separately to get the values of x. Then if that particular quadratic equation has the value of a more than 2 or greater than 1, 2 or more, then in that case you will have to do the grouping. In which case you will multiply the value of a with the constant, you get a new constant, look for two factors of that new constant, in which when you multiply they give you the constant, and when you add they give you the coefficient of the middle term. Then of course, please remember how to factorize single brackets. Then finally you always have your answers as two values of x. Otherwise, once you practice this, you will find that it becomes easy. Otherwise, this is the end of our lesson for today. So next time, we'll do some more of this, especially for those who are doing the extended, the last two, completing the square and the quadratic formula. Yes.